In the beginning, the Big Bang. The universe as we know it began with a bang, a big one. Imagine all of space and time compressed into a single infinitely dense point. Then, about 13.8 billion years ago, this point exploded, flinging out energy and matter in all directions. This event, the Big Bang, marked the birth of our universe. In the first fraction of a second, the universe was an unimaginably hot and dense soup of energy and exotic particles. As the universe expanded, it cooled, much like a hot gas cools as it expands. This cooling allowed energy to transform into matter. According to Einstein's famous equation, E equals mc squared. Think of a boiling pot of water. As the water boils, it transforms into steam, which expands and cools. Similarly, the early universe, filled with energy, cooled and transformed into matter. This newly formed matter wasn't evenly distributed. Tiny fluctuations in the early universe acted like seeds, creating regions of slightly higher density. These denser regions would later become the birthplaces of galaxies. A cooling universe, from plasma to particles. As the universe continued to expand and cool, the primordial soup of energy began to change. Temperatures dropped, allowing fundamental particles like quarks and electrons to form from the cooling energy. Think of it like steam condensing into water droplets as the air cools. These particles were initially too energetic to combine. They zipped around at incredible speeds, colliding with each other in the rapidly expanding universe. Imagine a cosmic billiards game with particles bouncing off each other in a chaotic dance. However, as temperatures continued to fall, these particles slowed down. This cooling allowed them to interact and combine, forming the first protons and neutrons, the building blocks of atomic nuclei. Gravity takes hold, the first structures. With the formation of protons and neutrons, the stage was set for gravity to take center stage. Gravity, the force that attracts objects with mass, began to pull these particles together. Remember those slightly denser regions in the early universe? Gravity amplified these differences, pulling in more and more matter. Imagine a cosmic vacuum cleaner, sucking in everything around it. Over millions of years, these clumps of matter grew larger and denser. These were the seeds of galaxies, enormous clouds of hydrogen and helium gas destined to become the homes of billions of stars. The mystery of dark matter, an invisible hand. While we can observe the effects of gravity in the formation of galaxies, there's a mysterious ingredient at play: dark matter. This invisible substance makes up a significant portion of the universe's mass, yet it doesn't interact with light, making it impossible to see directly. Think of a ghostly hand, shaping the visible universe from the shadows. We can't see the hand, but we can see its effects on the objects around it. Dark matter's gravity is thought to have played a crucial role in galaxy formation. Its gravitational pull helped to draw in the normal matter, forming the massive structures we observe today. Section 5. Galactic Genesis, the birth of star cities. Within these giant swirling clouds of gas and dark matter, stars began to ignite. The immense pressure and heat at the centers of these collapsing clouds reached a critical point, triggering nuclear fusion, the process that powers stars. Imagine countless tiny sparks igniting within a vast cosmic cloud, illuminating the darkness with their brilliant light. These first stars were massive and short-lived, burning through their nuclear fuel quickly and ending their lives in spectacular supernova explosions. These supernovae enriched the surrounding gas with heavier elements, the building blocks of planets and life itself. This cycle of star birth, death, and rebirth shaped the galaxies we see today. Section 6. Spirals, ellipticals, and irregulars, a galaxy menagerie. As galaxies evolved, they took on a variety of shapes and sizes, much like a cosmic zoo filled with a diverse array of creatures. Some galaxies, like our own Milky Way, formed majestic spiral arms, resembling giant cosmic pinwheels. Others, known as elliptical galaxies, are smooth and oval-shaped, often containing older stars and less gas and dust for new star formation. These galaxies may have formed through mergers with other galaxies. And then, there are irregular galaxies, which defy easy classification, often displaying a chaotic mix of stars, gas, and dust. These galaxies may have been distorted by interactions with their galactic neighbors. Section 7. Galactic collisions, a dance of titans. Galaxies aren't static objects, they move and interact with each other under the influence of gravity. Sometimes, these interactions lead to spectacular collisions, where galaxies merge and reshape each other over millions of years. Imagine two cosmic dancers locked in a graceful but powerful embrace, their stars and gas swirling together in a dazzling display. These collisions can trigger intense bursts of star formation as gas clouds collide and collapse. Our own Milky Way galaxy is on a collision course with our nearest large neighbor, the Andromeda Galaxy. Don't worry though, this collision won't happen for another few billion years. Section 8. The Future of Galaxies, an ever-evolving universe. The universe is still expanding and evolving, and so are the galaxies within it. As galaxies continue to interact and merge, they will continue to change and transform. Imagine a cosmic kaleidoscope with galaxies constantly shifting and rearranging themselves into new and intricate patterns. The rate of star formation in the universe has been declining since its peak billions of years ago. As the universe ages, galaxies will gradually run out of fuel for new stars, and the universe will slowly fade into a state of darkness and silence. But don't worry, this cosmic fate is still trillions of years away. Section 9. Unraveling the Cosmos. The quest continues. The study of galaxy formation and evolution is a journey into the distant past and the vastness of the cosmos. Astronomers use powerful telescopes and sophisticated computer simulations to piece together the story of how galaxies formed and evolved. Imagine cosmic detectives using every clue and piece of evidence to solve the mysteries of the universe's origins and destiny. We've learned a great deal about galaxy formation, but many questions remain unanswered. What is the precise role of dark matter? How did the first galaxies form? What is the ultimate fate of galaxies in an expanding universe? These are just a few of the questions that continue to drive our exploration of the cosmos.